Okay, in this we are going to create a sketch for to start modeling a crankshaft. Okay, sketch, bring it on and hide the default absolute axis system, and let's draw a circle somewhere. Okay, and give the dimension radius 60, so 120, fit in all. Okay, then let's align this to this axis to coincidence, and let's keep this distance okay, this distance offset from 5 mm in the other direction. Okay, let's keep it as smart. Okay, now let's draw a circle somewhere of diameter 50, so diameter 50. Okay, and let's make these two coincident. Okay, and the distance between this and this axis is nothing but our crank radius. Let's keep it 45 mm. Okay, let's draw a tangent tangent to this. Okay, from this somewhere. Okay, and make this line to coincide. Okay, somewhere, and then again one more line. Okay, and this one gives basic shape of as usual. We hide this default constraints. It would be great. Okay, let's delete the unwanted segments. Okay, let's keep it here so that we can look everything. This one we don't need, this one we don't need, this one also we don't need, this one we don't need. This is what our basic structure of the crankshaft. Okay, looks fine. Okay, now let's start giving dimensions to constrain this from this to the x-axis. Let's keep it some 10 mm. Okay, let's take from this to this. Already it's constrained. Let's not give that, but we have to give this dimension, I think. The length. Okay, we should take another ways around. Okay, now the sketch is fully constrained. Let's exit the sketch. In this body, let's create a pad at some 15 mm. That's okay. Okay, let's create another pad. Let's create another pad. Let's create another pad in the same plane. So go to insert body. In this body, let's create a pad. Otherwise, we can do it in this sketch itself. Let's let's edit this sketch. let's create a circle somewhere here and give some 30 mm dia. Okay, let's align these two to coincident. That's it. Let's repeat it. Okay, let it be like that so that it would be nice in the future. Okay, now let's create another feature in the body 3. Okay, thus let's create a sketch. This sketch is going to be revolved around, so let's create a an axis first. Okay, and draw lines. Okay, the first step is for main journal bearing, and another step and third one to assemble the okay, let's keep it somewhere here and then it will be alright. Now start giving dimensions. Let's give dimensions. This dia, let it be some 7.5 mm. Okay, and this dia 10 mm. Okay, and then this dia some 25. Okay, this diameter is 30 and this dia is 40. Okay, 40 mm dia bearing we are going to use. Okay, now this distance, let us make these two to align coincident. Okay, so draw a line and do it. Let's draw a line to this. Okay, and let's hide all the default constraints. Cancel it, hide it. Okay, this one also let's hide it. This one also let's hide it, and these two to coincident. Looks nice. Okay, now this dimension should be 35 or 15 minus 18, 20. Okay, 35, and this dimension, let's give some 18, and this dimension should be somewhat 25. Okay, even bigger than that, because 30 mm spline will come. So let's give 45, and then this is some 15 mm. Okay, and these two 10 mm by that. Okay, let's draw another line from this end to that end. Now the sketch is fully constrained. Everything looks fine. Let's go for it. Let's go for it with the shaft command. Preview, okay. Now the crankshaft is getting the real shape. Okay, let's update it. And this one is wrong by look itself. Edit definition, this dia is too small. 25, this should be somewhat 20 or 17.5. Okay, and this one should be 12.5. Okay, now sounds good. Okay, balancing will be better. Now take in this body itself. Okay, let's assemble this body. Assemble this body to the part body. Okay, and assemble this body to the part body. Now sounds good, and we can split it later also if we want to make some other process. And again, if you take in this part body as a defining workbench, some symmetry of this preview. Okay, almost done. Okay, now go for another body, and in this body create a sketch in the middle plane. Okay, hide it all. Okay, draw a circle of diameter 30, that's for crank pin, and align these two to coincidence, and give from this to this at a distance of 45. Am I right? Yes, it's exactly. Give it, and create a pad, some 45 mm, maybe too high, no problem. More, this is a 40 plus 6, 40 plus 30, 70. Okay, 35 and 35. It fits fully. Okay, let's see whether it is getting assembled or not. This is the real type of challenge. It won't get anyway. Assemble or add to the part body. Preview, okay, no issues. Now this part body is exactly added. This is what our basic crankshaft assembly. Okay, in the crankshaft. In this basic crankshaft, well balanced. Let's give some edge fillets. In this, it does okay. 5 mm radius edge fillets. Preview, okay. Let's give some one more fillet of some 15 mm radius at these 4 points, so that the stress concentration in this area will be smoothened. View, okay. Now seems good. This is what the basic structure of our crankshaft assembly. Okay, thank you for watching. Simple